Okay, with this video we're going to look at dividing with like bases. So previously we've looked at how to fix negative exponents and what to do if we're multiplying and they have the same base. For example, like a to the second and a to the fifth, how we get that answer. Okay, today we're going to be looking at what we do if we divide. So what we already know, first thing here, you can't have negative exponents. If it is negative in the top, it moves to the bottom. And if it is negative in the bottom, it moves to the top. And then the exponent becomes positive, whatever that exponent is. And that's the first thing we want to fix on any problem, is get rid of negative exponents. It makes our problem a lot easier to work with and a lot easier to simplify. Second thing we already know is that when we're multiplying, we add the exponents, because really what you're doing is you're telling us how many there are. So the example that I used earlier, a to the second times a to the fifth, that's really 1, 2 a's, and then 5 more. Total there I have 7. Really what I've done is added those exponents together. Okay, both of those we already know. We've looked at those. Today we're taking that one step farther. When we divide, what we do is we write it out in expanded form. Okay, by that I mean what I just did with the multiplying problem, however many a's there are total. We cancel anything that makes 1. Remember, anything over itself becomes 1. So for example, 3 over 3 becomes 1. If I had variables, x over x becomes 1. And 1 times anything is itself, it doesn't change. So really what we're doing is making 1s. Now, along with that, you want to reduce coefficients. Your coefficients might not be the same like they are here with your 3's. We're making 1s out of the variables, but we want to reduce our coefficients. Okay? Then we combine everything back, if necessary, be the multiplying piece that we've already talked about. And then finally, that's your answer. So here we've got a nice short example. Okay, we have 6 over 2, and then 6x to the fifth over 2x squared. So I'm going to write out the 6 over the 2 and write out my x's in expanded form. Okay, so those two would make a 1, and those two would make a 1. All right, and I am left with 3, so x cubed. Now, again, I reduce my coefficients. I divide them. 6 over 2 is really 3, and there's my answer, 3x cubed. Okay, it's that easy. Now we are going to throw in more variables. Okay, coefficients are going to be about the same, but we're going to throw in more variables, which means you're just looking for more things to reduce down or cancel out. Okay, so here's some examples, and on these I'm going to give you a shortcut. Now I'm not going to give you the shortcut until we get to the second example. We're going to do the first one in expanded form. So I've got 24 and 8 as my coefficients. So I'm going to write those first. Now in the numerator, I have a to the fifth, which is 5a's, b cubed, which is 3b's, and c to the sixth, which is 6c's. In my denominator, I have 4a's, 8b's, 1, 2, 3, 4, 5, 6, 7, 8, and then 1c. Now we're looking for things that cancel, that reduce down. Those a's, those a's, those a's, and those a's, and I'm left with 1a in my numerator. Okay, these b's cancel, and I'm left with 5b's in my denominator. And then I have one set of c's that cancel, and I'm left with 5c's in my numerator. So I have a c to the fifth over b to the fifth. That's the variable component. Now, I divide my coefficients. 24 over 8 is really 3, or 3 over 1. Okay, and there's my answer. All right, that easy. Now, the shortcut I'm giving you here on the second one is we are just subtracting. Okay, now the trick, if you're going to use the shortcut, I like the expanded method because it always works. I can write everything out and I will cancel. I'll see everything and I'm going to put it back together. It's great. That's the way I would recommend start doing your problems. when we divide, okay, division is the opposite of multiplication. We multiplied last time and we added our exponents. So when we divide, we're going to subtract our exponents. Now the problem is we get this shortcut confused sometimes and people get problems wrong when they try to use it. So again, I would recommend doing the expanded one, but if you want to give the shortcut a try, go for it. What I'm going to do is write each component out separately. Y to the 6th over y cubed, and that z is over nothing. Okay, sorry, z squared. All right, so I treat each one of these separate. Now, my coefficients, I divide. I don't subtract here. 7 over 14 is really 1 over 2. Here, with all of these, okay, I want to take the bigger exponent minus the smaller one every time. So on this one with my x's, I'm going to do 10 minus 8. 10 minus 8 is 2. Now, the bigger exponent is in the denominator, so I'm going to put x squared in the bottom. Okay. On the next one, same idea. I do the bigger exponent, 6 minus 3. Well, 6 minus 3 is 3. And the bigger exponent is in the numerator, so I have a y cubed in the top. Now that z didn't have anything to pair with, so it just stays where it's at. And there's our answer. Now that shortcut, like I said, I don't know if that shortcut's any easier. You're still writing stuff out. I like the long way over here, and again, that's how I would recommend doing it. We're going to add a layer to this. Now we're going to add in some negative exponents. And like I said earlier, move negative exponents before you start doing anything. Okay, before you start canceling or subtracting if you want to use your shortcut. I'm going to do the canceling method. Okay, this might also mean you have to multiply before beginning to divide. You might have to combine some things together. So here we've got an example. We have 9 over 15. Okay, but I have a negative exponent here and a negative exponent here. Well, we said it's negative in the denominator, it moves to the numerator. If it's negative in the numerator, it moves to the denominator. So I have an x to the 5th already in the bottom, but I'm going to move an x squared down there with it. I have a y cubed in the numerator, but I'm going to move a y to the 1st up there with my negative exponent here. Now here, I've moved my negative exponents first, but now I'm going to multiply them together. So I have 9y to the 4th, and remember when we multiply, we add our exponents, over 15x to the 8th. Okay? Now if I look at this one, I can write out my 4y, and I can write out my 8x's, but is anything going to cancel? No. So really, I'm going to leave it y to the 4th over x to the 8th. But I do need to check and see if these reduce, if those coefficients reduce. And you can use your calculator for that. You can plug it in as division, 9 divided by 15, and then hit enter. It'll give you a decimal, and find the fraction key, the frac key on your calculator, and it will change it to a fraction for you. Okay? Well, I know that both of these are divisible by 3. 9 goes into 3 times, and 9 goes into 15. 3 goes into 15 5 times. So if you're going to use your calculator, you'd get 3/5, top, bottom. Okay? There's that example. So that's when we add negative exponents into it. Got a couple more examples here. Okay, first thing we're going to do is move the negative exponents. So example 1, we have 15a to the negative 3rd, b to the 6th over c, over 3a to the 4th, b squared, c to the 5th. So that a to the negative 3rd has to move to the denominator. 3a to the 4th, a to the 3rd now because we moved it, b squared, c to the 5th. Again, I'm going to use the expanding method where I cancel and look for 1. So I'm going to leave my coefficients where they are. I have 6 b's up top and 1 c. Now on the bottom, I need to multiply these together. That's really a to the 7th. So I have 7 a's down there, 2 b's, 5 c's. We're looking for things that cancel. Now, I wrote this a little sloppily. You can stack them on top of each other. That's a good idea. Put your variables on top. Since I had so many a's down here, that threw it off a little bit, but this b cancels that b, and that b cancels that b, so I am left with 4 b's up top. And then I can cancel 1c from the numerator and the denominator. So I have 15 over 3 b to the 4th in my numerator, and then 3a to the 7th, c to the 4th in my denominator. Finally, I got to go back and simplify those coefficients. Well, 15 divided by 3 is 5 over 1. And there is your final answer. 5b to the 4th over 1a to the 7th, c to the 4th. Do one more here. Again, we start out by moving negative exponents, and I have a lot of them here. So 28 over 18, y to the 5th. Okay. In the denominator, I have x squared, and I'm moving down an x to the 4th. Y squared is down there. And then these two z's are trading places. The z to the 7th is moving up. Z squared is moving down. Okay, I'm going to combine things that I have now. So I have 28 over 18, y to the 5th, z to the 7th, over x to the 6th, y squared, z squared. We can write that out in expanded form. 28 and 18. I have 1, 2, 3, 4, 5 y's up top. 7 z's up top. I'm not going to do anything with the x's because I noticed that they don't have anything to compare with. So I'm just going to leave it x to the 6th. And then 2 y's and 2 z's. Well, those y's and those z's all cancel. So I'm left with 28y cubed z to the 5th over 18x to the 6th. Again, I have to finish by simplifying those coefficients. 28 and 18. Well, both of those are divisible by 2. 28 is divided by 2 is 14. And 18 divided by 2 is 9. And 14 divided by 9 won't simplify. So there we are. 14y cubed z to the 5th over 9x to the 6th. Okay, I have 2 more examples here. What I would recommend you doing is pausing them and trying them on your own, and then coming back and checking to see if you've got your answer correct. Okay, now that you've paused it and tried them on your own, I'm going to work through them. So here, skipped a page. -4 over 12. My n's are going to trade places, and this p is going to move up to the top. So m to the 5th over m to the 9th, n to the 4th, and n to the 1st, and up top p to the 8th, p squared. So this time I'm going to use the subtraction when I do these. So -4 over 12, I'm going to do 9 minus 5, and that is 4, and 9 is bigger, so they go on the bottom. Here, 4 minus 1 is 3. And the 4 is bigger, so I put the n on top. These two, I'm going to add their exponents, so p to the 10th. Okay, and then I have to divide my coefficients there. Do not let the negative coefficient throw you. It stays where it's at. So there is our final answer. -1 n to the 3rd, p to the 10th, over 3m to the 4th. The next one here, my m is going to move, my n is going to move, and my p is going to move. So 7 over -28, m cubed, m to the 10th, over, and everything else is moving down to the bottom. P2. Okay, I noticed that they're all on the same level here, so I'm going to go ahead and simplify these. That would be 1 over -4. M to the 13th, n to the 11th, p to the 3rd. And nothing cancels there, so that would be our answer. Okay? Quick recap. When dividing, you can either write out the problems in expanded form, and that's how I'd start doing these, or use the subtraction shortcut, which is what I used on the last set there. Make sure you divide your coefficients, and if there's any negative exponents, get rid of those before you start dividing. You might have to multiply, combine things together before you start to simplify. If you have any questions, let me know. Good luck on your homework.